Hi, and welcome to Maths Appeal. I'm Bobby Seagull.
And I'm Susan Okereke.
And our aim is to make maths accessible for everyone. Here's a question for you, Susan. When you tell people you're a maths teacher, what reaction do you generally get?
Generally, some 9 out of 10 times, I'm met with a look of horror and I hear something along the lines of, "Oh my God, I was rubbish at maths at school." And that's not always the best way to start a conversation. So sadly, the response is often really negative, but I'm sure I wouldn't get that if I was a geography teacher or a history teacher, which is a bit of a shame.
Yeah, it's the same here really, and that's part of the reason why we're making Maths Appeal, because we really want to show that everyone can do maths and they might actually enjoy it as well.
So every week, Bobby and I will focus on a specific fundamental maths topic and share our experiences of teaching it in the classroom, also reflecting on what we've observed are the main difficulties in grasping the topic, and we'll discuss how these topics relate to everyday life.
You know me, I love a good quiz, so I'll set a puzzle or a question related to that topic.
And to give everyone time to work out this puzzle, we'll then hear from a special guest. And this week we've got the second part of our interview with math legend Johnny Ball.
If you missed part 1, and why, have a listen to our first podcast. And in part 2, we discuss teaching methods around the world and over the decades to talk about how we can make maths more engaging at school.
And then we'll return to Bobby's puzzle and compare our answers and discuss how we got our solutions.
But before we tackle today's topic, types of numbers, I just want to quickly say thank you for choosing our podcast when there are so many out there to choose from.
If you can subscribe, tell your friends to subscribe, and even give a nice rating, we'll give you a virtual high five and send you very good maths vibes.
Yeah, and you can also find us on Twitter and Instagram. We're at Maths Appeal. So come and say hello.
So let's get into it. Let's talk about types of numbers. So what we're thinking about here are things like understanding the difference between odd and even numbers, thinking about times tables, square numbers, cube numbers, prime numbers. These are all special numbers that have relationships, and we want to think about how best to deliver them. So the way we break down this section is we set 3 questions that Bobby and I think about, and then we discuss and share our answers as teachers that obviously have different styles. So the questions that we reflect on are: what first comes to mind when you think about this topic, types of number? 2, how do you teach this topic or introduce it to your students? And 3, what are the common issues that arise when teaching this topic? So, Bobby, tell me, when you first started thinking about this topic, what first came to mind?
Sheep. You know what? Do you know why?
Tell me.
We count sheep. 1, 2,
yes.
3 sheep. And again, these are people's first experience of numbers.
Yeah.
And these are called the counting or the natural numbers. So not a 0. I mean, some people do include 0, but 0, 1, 2, 3. And that for me is like the basis of numbers. But also one thing is that I always find the word numbers is less scary than maths.
Yeah.
Yeah. So if you say talk to me about maths, people get a bit scared. But numbers, most people feel that they can count.
Yeah, that's good. When I thought about the whole idea of types of numbers, it kind of was something that I really enjoyed when I was doing my degree. Took the idea of like setting things. I quite like ordering things, putting things into specific groups, looking at relationships. But I also kind of realised that with a lot of these things, it's really to do with patterns. And that's something I think that can sometimes be lost when we're delivering it. We kind of maybe focus just on how the numbers look as opposed to what they might look like on something like a 1 to 100 grid. And that, when I think about times tables, a 1 to 100 grid is kind of an incredible resource. And also another thing when I first thought about it was when I teach students, a big difference between students who do really well, I think, or perform well, is a lot of them are very confident about these number facts. Yeah. So they kind of have them as a default. So you were to ask them about square numbers, they'd know them without thinking about it. If you ask them, like what the 6 times table was, they'd kind of know what it is without having to think about it. And just by having that as a base, and learning it the variety of ways, that is incredible amount of advantage, I think, for being able to access more complex things.
Yeah, it's like the numbers are like the things like the number bonds, the number facts, the times tables. These are the absolute critical building blocks. And without these, even students that are bright and capable, they're going to flounder when we get to more challenging maths at, year 9, year 10, year 11 at GCSE. Yeah. They need these sort of number facts completely bolt on.
So when I try and introduce and get students to sort of think about learning these facts, I like to start visual. I know that there's been a bit of a debate about should we do rote learning, should people kind of understand what's happening in a more kind of conceptual way. I personally think it's a bit of both. So I think the introduction visually, where you have, as I say, if you think about times tables, if you think about 3 times 4. You know what arrays are? Of course, yeah. But for people who don't know what arrays are, it's effectively like dots in rows. So 3 times 4 would effectively be 3 dots in a row, but there'd be 4 rows of them. And if you were to say it'd be 3 times 4, and that would equal, if you counted all the dots, that would be 12. And you can do that with every times table.
Yeah, and I've actually used that method with some of my students that really struggle with numbers, even ones that have like dyscalculia. Have you heard of dyscalculia? It's almost like the equivalent of dyslexia for numbers. It's where people have like genuine sort of learning difficulties with numbers. And I've done the dot method.
Yeah.
And it really helps them to see, I can see what 3 times 4 is.
And it's amazing as well for kind of being able to reverse that and then seeing that, 12 divided by 3 is 4, or 12 divided by 4 is 3, and it's the relationship there. And I think a key thing for learning these sort of number facts is really to kind of connect them to what they look like, like through arrays. And so things like square numbers, you do it as an array, and that's effectively, it looks like a square. So 2 times 2 is 2 across and 2 down. 3 times 3, 3 squared is 3 across and 3 down, 9. And it's that thing of once there's a visual, some people are much better at remembering these things when it's connected to a visual, which they don't have to remember later, but as they're learning it, it's quite kind of useful. And also the idea of the 100 square, we've got 1 to 100, but it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then you kind of have like the 20s, the 30s, the 40s, the 50s underneath, up to 100. And then getting students to colour in all the odd numbers, and they see that they're effectively in columns, or getting them to colour in the 5 times table, and you notice that it's all the numbers that end in 5 and all the numbers that end in 0.
Yeah.
And suddenly you're able to kind of notice things and make kind of decisions, efficient math decisions about what to divide by or whatever, because you kind of know without even having to work stuff out. I mean, that's where I think a lot of people's confidence in maths can really jump when they know these kind of basic facts and they're like in them.
Yeah. Actually, when you were talking about the visual and the diagram, I actually was thinking of the Singapore method.
Okay.
Because, they've got this like 3 stages, the concrete, the pictorial or the visual, and the abstract. And the concrete's like when we first start out with the blocks. So, the Dean blocks, or you're counting things 1, 2, 3, or 1, 2, 3 cars. And the pictorial is when they can see it on a piece of paper, whereas the 3 cars, or the colour, the patterns of the 5s and the 10 times table. And the abstract is what we're trying to get them to do, just to think of the numbers. Because ideally, we want students to move away from the sort of the grid method of, putting 3 dots in 4 columns of that, to actually thinking in their head, 3 times 4, I can see that as a number 12.
But also I think what you kind of want longer term is beyond that is when you're introducing it, yes, I think the arrays are useful, but you kind of want to be able to say to somebody 3 times 4 equals 12 without even have to think about it. And that's like the bigger picture, isn't it? It's like not having to think about the working out, because actually that takes up a lot of your working memory. And actually there's a game. So like I like to introduce it visually, but then my target is to get the kids to just know it. And have you ever played ping pong?
No, I mean, I play table tennis.
This is a maths game, ping pong.
Oh.
And how it was like call and response. And things like, so say we were to do square numbers. I'd say ping, you'd say pong.
Pong. And
then if I was to say 3, you'd say
9.
Squaring 5 is
25.
Right, so how you do it is to try and the game is you're meant to do it in a smooth rhythm. So I say ping,
I say pong.
Pong, yeah. I say 4, you'd say
16.
I say ping,
I say pong.
2,
4,
ping,
pong.
3,
9. It's like a rally going on.
Exactly. And so the whole point is over time it should be quite a smooth thing, and it's actually you're jumping around, and you can do that with number bonds to 10, you can do that with times tables.
I love that.
So it's just
I'm going to steal this from my class.
Totally. It's really it's surprising as well how engaged they can be. So that's like the bigger picture. And so on the back of that then, so when you're delivering this, what are the big issues your kids have?
I think with numbers, just to make sure that they realise that certain things are the same, like 1.0 is the same as 1, which is the same as 10 over 10. I mean, these are topics that we'll discuss in future podcasts, but they seem to think they're different things, but actually numbers can be equivalent.
Yeah, I think as you say, it's the different ways of representing things. But for me, is a big thing is just trying to get them to remember over time. You know, that's like the biggest aim, and that's where a lot of students, I think, because they're just thinking about what the number is, and they get really worried about working it out. Trying to get them to just know it without having to think is kind of the key.
Reduce that working memory load you're thinking.
Yeah, so working memory load, and also what it comes down to is practice, and hopefully as well, not just at school, but also parents at home can play games with the kids, because the games are where people that's how people learn to count.
Yeah, gamification, that's the word.
Well, that's what we I'm hoping to try and encourage. But that would be like a massive aim, I think.
Or podification, getting people to learn through podcasts.
Hey, here we are. So talking of gamification, Bobby, you've got a puzzle for us based on types of numbers. So hit it.
So it's a Christmas gift for you. So ahead of Christmas Day, a grandmother met her 2 grandchildren. They said to her, "Sorry, Grandma, but we forgot to get you a Christmas gift." Bad grandchildren. So instead, we have a mathematical treat for you, Grandma. I've noticed that if you square my age and square my younger brother's age and add the total up, and then finally square root that total, we get what your age was 50 years ago. Okay, firstly, very clever grandchildren. But the puzzle for our listener is, assuming there's a 3-year gap between the 2 children, and the grandmother is not yet old enough to get an official 100th birthday message from the Queen, what are the ages of the grandmother and her 2 grandchildren?
So one more time, Bobby. So I've got half of that information down. So one more time, tell me.
So the grandkid said, if you square my age and square my younger brother's age and add that total up and then square root that total, they get the age of their grandmother 50 years ago. And then you have to make an assumption that there's a 3-year gap between the ages of the 2 children, and then the grandmother is less than 100 years old. So you have to work out the age of the grandmother and the 2 grandkids.
And they didn't buy her a present for her birthday.
They got a maths puzzle. What more do you need?
You're quite right. So while you're working this out, let's hear from one of Britain's best-loved maths champions, Johnny Ball.
You might remember him from his TV shows like Think of a Number, Know How, or Johnny Ball Reveals All. He's also written loads of books, and in this part of the interview, we talk about his latest one, Wonders Beyond Numbers. So you hear references to names like Gauss, Euler, Newton, Einstein, Turing, and Kekule, some of whom you may know, but some of whom you might not.
Johnny also mentioned his maths musical and stage shows. It's kind of amazing to realise how far and wide his maths message went over the decades. But as he says, he's never been a maths teacher. So in our conversation, we discuss maths education and attitudes towards maths. Over to you, Bobby.
Do you think there are differences in attitude towards mathematics in different countries? Like, again, I'll compare my family originally from India, my parents are, and my cousins in India, they all are better than my cousins in the UK. We're all assuming we're all from the same gene pool, not being naughty. Yeah, no.
Yes. Oh, yes. And the Chinese. You know, I don't think anybody in China or India. I don't think one parent says, "Oh, I hated maths. Oh, I hate maths." I don't think one parent does it. I don't think one parent would ever dream of doing that in front of their children, but we do. And it's all the time.
Yeah, it's funny because I think actually it's a bit of a problem for Britain, and I think America on some level. I think loads of other countries, and that's like across Europe even, I think are actually generally they have a much more respectful attitude to mathematics, but in Britain definitely not.
And there's another side to this coin. Which they brought China. What happened then? They announced they were bringing. Oh right. They announced they were bringing 100 Chinese teachers a couple of years ago.
Yeah.
Well, that was when my book, Think of a Number, was selling, I don't know, 60,000 a year in Beijing alone.
Oh, wow.
And it's my maths book, you see. And it's selling over there. The thing about it is, it's not necessarily so that the fact that they get on with maths and work so well and their work ethic is so good, it doesn't necessarily mean that when they become adults, they are good at lateral thinking.
Mm-hmm.
It's very often, and what Chinese teachers said, they had a lot of bad things to say about British education, no question about that. But they had some good things. And one of the good things they said, your kids are a joy to play with and to work with because they're so diverse and they all have their own personalities and they're not regimented, and we love that. And from that you get lots of different questions and different way of exploring mathematics, and we love that. We don't get that in China, and you don't get it in Singapore and things like that, because it's a more rigid system. But the rigidity can mean that although you function well and your results are brilliant, you aren't necessarily going to be a lateral thinker because you haven't practiced lateral thinking, because your mind hasn't been allowed to go left or right. It's down the corridor of education.
So the lack of creativity on some thinking.
It can be, and I'm not saying it's a general statement, but I'm trying to defend our maths teaching. Sometimes I wonder why. However, but I think it's one. I've never taught. You see, I never get the same audience twice. That's what I mean by I've never taught. Of course I've taught, and of course they pick things up from me, but I can pick and choose and take them to places that are exciting, you know.
So when we do our lessons, we've got our exciting wow lessons, but we've got a lot of lessons that just need to get through material that's not so exciting.
Yeah. I mean, I think one of the big issues, I think we've talked about this before, is the focus on passing exam results, which I think, you know, is necessary on some level in the this day and age, but it does kind of hold the subject, because we're trying to get kids ready to pass an exam over loving the subject, over really taking in, you know, the wow wonder
That's
of it.
Right, and you don't have time. The curriculum doesn't allow you the time to go off into tangents as much as you should. So I've said to teachers, and I said, please forgive me if you think this is impossible. And it's more impossible now than it was when I spoke 20 years ago, but 20 years I think it was possible. I said, if you can teach the maths curriculum that is there for you to get over this year, if you can teach that in half the mathematics time and take them where the hell you want to take them in the other half of the mathematics time, you'll find they'll love maths much more, and they'll even do the maths you want them to do on the curriculum much better, because of the variety they're getting and because they've been allowed to think sideways. So that's easy for me to say if I'm not a teacher. If you can teach it in half the time, you know. I know. But some teachers have come back and said, "Oh, I always have." You see, and some people have said, "Oh, you can't. It's impossible." You know, and so it varies. And the other thing is, with teachers, you've got to conform with the team you're in each school. You know, and so you've got other constraints there. It's very difficult. But now there is no extra money. So you don't get people coming in enthusing about the subject. You don't get people coming in talking about the subject. Not so much, you know.
There's nothing on television to encourage.
There's really, nothing there, you know, it's terrible.
Maybe talk a little bit about your book, because with regards to, because it's effectively the history of...
Yeah, so I got it recently, and I'm already I've dipped in and out, and I just love the idea of someone taking through us the whole of mathematics. Yeah. So I found some writers have specific periods that they prefer, and they just focus on that. Whereas you've just taken us through the whole. Well,
that's 480 pages. Yeah. Believe me, I get to Gauss, and not even the bit around him, and Euler, and I get to them, and I get to Newton, and I get to Einstein, and even a bit of Turing, but there's nothing around them, and of course, there's a huge phalanx of mathematicians that I haven't, because that would take another 480 pages, because it gets richer and richer, you see. So finishing the book was the most difficult. That's why the chapter 14 is the simple mathematics that underpin science. And I mean the simple. I mean, for instance, Faraday, who was never considered a mathematician at all, he was the one who said, hydrogen's different to oxygen, and that's different to carbon. They've got valences. How the heck did he know? How the heck did he know that hydrogen has one hand, that oxygen has got two, that carbon might possibly have four? How did he come up with that? And then you get Kekule, who wrote these little diagrams, sausage diagrams, and then he dreamt of the ring of the carbon atoms like monkeys grabbing each other's tails, and it's beautiful. So that is such basic maths.
So it's a real shame that there's not more promoting maths currently, in the general psyche, if you know what I mean.
They don't understand. So I go to book fairs at York, Penley, and they said, you did pull the biggest audience for the whole festival.
Wow.
And you sold more books,
People do love maths, It's weird. I think it's a weird, kind of unwritten narrative. Well, it's not written that it's like people don't like it, but actually, day to day, even though it's challenging, I know people love it. I know kids enjoy it, but they also...
They don't like admitting it? Or?
Yeah, they don't like admitting it, but also I think that some of them have heard their parents be so negative about it that they believe that they don't like it, even if they're weirdly enjoying doing some work. It's such a strange thing to be trying to fight.
Yeah. I once wrote a rap, but I never used it. And what I did, and it was a rap for basically 9 to... Oh, this is the other thing I've always done with the musicals. I'm a roadshow. The shows are for 9 to 13-year-olds. And education said, well, you can't do that. That's primary and secondary.
Oh, it's necessary. Oh, it's so necessary. There's a massive drop-off of students' enjoyment and love of maths hitting 11 really when they go to secondary school.
Yeah.
So they're primary school. They generally. I mean, this again. Having read a bit of stuff.
Schools are very bad at tying it together.
Oh, it's massive.
At tying it together.
Yeah.
They go ploughing on and say, "Do you know this? Have you done this? Oh heck! Oh well, never mind. We'll plough on." Instead of recapping, you've almost got to come back. I worked with and did a report on what was required for the curriculum to improve it, because since the 50s there's no question that maths is being taught much slower now.
Oh wow.
Okay? And much slower now. When's trigonometry taught now?
GCSE sort of. Yeah.
13.
Yeah. But
I taught myself.
But you were gifted, not gifted, but you're obviously confident with it. There's a lot. I think you were probably in top set in school, Bobby. Yeah. You obviously very capable. I was at top set at school, and having now taught a variety of kids from a variety of backgrounds and also from a variety of attainment sets, and when you're confident in maths, even if you find it difficult, your basics are quite good. What's mind-blowing for me over the last few years is just seeing how many people's basics are really poor.
So the times tables.
It's really basics. Also, number bonds to 10. When you say to a child, what makes 10 from 7,
6 and
but
4.
some of them are counting in their hands. I mean, if you don't have that, there's no way you can...
Yeah, that's right. Which is why I say the numbers have got to be up there, and and the answers are going to be up there for them to see. And if you want to do that, you go 1 to 10 and 10 to 1 the other side.
And when they see it, it's beautiful.
They're all opposite each other, and the pattern's there.
But I think it's playing around with the patterns and all that stuff, but it's something that secondary school teachers, well, definitely for me, the time element, you feel really pressured into moving on, when actually that's the one thing you shouldn't do. You should spend your time making sure the kids understand and playing around with it. And I think that's the real challenge I think a lot of us have, is how much time do you spend playing or trying to play, and how much do you have to get through to the next test or whatever. This has been wonderful, Johnny.
Thank you very much.
So wonderful. You really have. It's been great to hear your story, and to kind of remind us why we're doing it as well. Yeah,
exactly. You inspired millions of people in this country to have a positive view of that.
Yes, it's been absolutely lovely, and to think it was something that wasn't planned, that slowly unfolded. That's the joy of it. It really is.
So that was really brilliant, sort of meeting him, wasn't it?
It was just a sense of enthusiasm and joy again just comes through, it emanates from the interview.
Yeah, and it's funny. He is sort of saying a lot of the stuff we were talking about before about students being confident with number and things like that. But it's interesting. There's a lot of challenges that he, as he says himself, he's not a teacher, and this whole idea of encouraging the joy and the play of mathematics, and how I think a lot of maths teachers really do love it as a subject, but the sad thing is when they go into the classroom, there's so many other pressures, and we are encouraged, well, it feels like we're encouraged to plough on and to go through, even if the students aren't necessarily getting it, but we've got a test in a few weeks' time.
Schemes of learning to plough through.
And, and that whole, him encouraging, telling us to go off on a tangent, which I think is amazing, but can you imagine finishing the work, kind of teaching everything in half of the time?
So if you're a teacher, you're probably laughing at that.
Yeah, because That's not very...
Nah, it probably won't happen in my class.
No, but I mean, I love the sentiment of it. I think if we were to encourage more play within the classroom, there'd be a lot more people who would say they love the subject and would be much more inclined to take it further. But that's kind of trying to strike that balance is actually quite tough. But, you know, speaking to somebody who is obviously maturer, legends as he is, but still so enthusiastic about it was really brilliant.
Yeah, I think to have, you know, Britain needs more people like him just leading the way and saying maths is cool, maths is fun.
He also talked about maths rap, and Melissa didn't get a chance to really hear it because he kind of went off on his own tangent.
I guess you've got me in the studio today.
Do you have any bars to spit?
Again,
Bobby?
yeah, I do. Although my students normally, they would tell me off because normally they say, Mr. Seagull, you can't do any bars without a backing track. But I'll go a cappella.
Do you want me to do a beat for you?
Yeah, go on.
No, sorry.
Oh, okay.
Sorry. I don't think. Should I?
Have a go. Okay. Students say, Mr. Seagull, you can call me Bobby. You see, maths and me is more than just a hobby. 2 2's the 4 and 4 2's the 8. Starting with your tables would be just great. Trigonometry is all about the angle, ratio, sine, cos, but don't get in a tangle. Area of a circle, pi r squared. Pi times 2 r, circumference if you can. Y equals m plus c is just a straight line. And the gradient, see the intercept be mine. Numerator over denominator. Better get it right, Mr. Seagull. Oh, I think I messed up the last bit, but who cares?
Oh, sorry, I just in, beat out. Yeah, smash that. Maths appeal in your face. Whoa, yeah. Okay, well, I think that's time for us to go through the puzzle.
It is.
And so, can you recap it? Is that okay?
Yes.
Mr. Seagull?
So, we had 2 clever little grandchildren and their mathematical puzzle for their grandma who will have no presents.
It's a bit of a shame, but that's okay. We'll continue.
Okay. So, the treat was, one of the grandchildren said, if you square my age and square my younger brother's age and add them up, and then you square root that number, you'll get the grandmother's age 50 years ago. And the assumption was there's a 3-year age gap between the 2 children and the grandmother is less than 100. So what are the ages of all the 3 people?
Wowzers. I have to say, when you first showed me this puzzle, I was like, what's happening? But then obviously, like, the first thing I would do is write down the information that I'm given. Okay. And then I'll be really interested to see how you did this, because I put it into an equation, which obviously not everyone's going to do. But by putting it into an equation, I noticed that the 2 ages squared, added together and square rooted, plus 50 is the grandmother's age. So I effectively took 50 off. So that meant the 2 numbers added together and then square rooted are also less than 50, because 50 and 50 are 100 and it's less than 100. So I took 50 off. Following me?
Yeah.
Yeah. So. And then from there, seriously, all I then did was I took the numbers starting from 1 and then added on 3. So I did 1 squared plus 4 squared.
Yeah.
Which is like 17, and I did that for all of them until I got to a number.
It's like you're looking at my notes here almost.
Oh, did you do the same?
Well, that's a sort of my outline of a possible solution.
Yeah, because then I was like, oh, is there like an easy way of doing this? And actually, no, I don't think there is. I literally went through adding up square numbers. So 2 squared plus 5 squared didn't work. 3 squared plus 6 squared didn't work. 4 squared plus 7 squared didn't work. Went all the way down to 9 squared plus 12 squared, which is 81 plus 144. Added them together, 225. The square root of 225 is 15. And then that effectively is the age plus 50 for the grandmother, which was 65.
Perfect. Yeah, and I think this is an example of a question where you probably need like a bit of pen and paper and a bit of brute force. The only thing that I might add in terms of speeding up possibly is 9, 12 and 15 is what's called a Pythagorean triple. That's the only thing that would have meant. So you're trying to get one square number plus another square number
equals a square number.
Another square number. So it's like a triangle, a right angle triangle. So one side, one number squared plus another number squared. If you add them both up, you get the other number squared. So again, in maths, it's called a Pythagorean triple, where you get like 3 squared plus 4 squared equals 5 squared, or 6 squared plus 8 squared equals 10 squared, even though that's not a unique one.
Oh, right. But for the people who the whole Pythagorean thing is, some of you might remember from school days, A squared plus B squared equals C squared. That's kind of where that comes from.
Yeah.
And Oh, I didn't even think about that. I did it brute force, worked my way through.
But the brute force it'll get you there.
Yeah, totally did. Oh, okay. I felt quite proud of myself after, I'm not going to lie to you.
Yeah, well done. That was a tricky one. That was a tricky puzzle.
So, how did you get on with that? If you want to contact us about the puzzle or our methods of working out, get in touch on Twitter or Instagram. We are at Maths Appeal, and we're going to share our solutions as well. So we put photographs of those up as well.
Absolutely. We really hope you've enjoyed this podcast, and that you'll join us next week, where we'll be getting to grips with fractions and decimals, as well as hearing from Alex Bellos, Guardian puzzle writer and author of Alex's Adventures in Numberland.
Please help us share the maths love by subscribing to this podcast, giving us a 5-star review, and recommending us to your friends.
And I thought we could finish off the day with another maths fact. And actually, this one was my original edition of my book, The Life-Changing Magic of Numbers, but didn't quite make the cut. So this is like a special. So we were talking about the whole numbers, the counting numbers.
Yep.
0, 1, 2, 3, 4.
Mm-hmm.
If we extend that backwards, like -1, -2, -3, we get what they call integers.
Yep.
So these are all the whole numbers, negative, 0 and positive. And actually, mathematically, if you're writing down integers, you represent it with the letter Z.
Oh, yeah.
And students should actually see this by GCSE, but the Z is like you think, where did you get a Z from? And it comes from the German Zahl, Z-A-H-L, which means number.
Oh.
So integers are all represented by the letter Z.
Oh, I did my degree. I had no idea about that. Thank you, Bobby.
A bit of Deutsche for you. Sprechen Sie Deutsche.
Bitte. Thank you very much. That's great. And so on that, I'm going to say goodbye from us. This has been Maths Appeal. It's been presented by Susan Okereke and Bobby Seagull. The music's composed by Kelly Okereke, and the image design is by Calix Davis. And the producer, our love producer, is Jenny Nelson.